Hey VC students, welcome to another video of hok'stutoring. Today we'll be going through a tutorial video covering through chapter 3J question 13. So this is the very last question of the matrices, or in this case the transformation chapter, and it's essentially we're just going to be doing the same thing again, as in finding the equation of a new graph given an old equation, but this time it's going to be through fully through matrices. So no mapping involved, all of it through matrices. So let's get into the video. Let's get into the question. So question 13. A transformation is described by the equation ax plus b equals to x prime, where a is your, this matrix right here, which is your dilation and your reflection matrix. And then b is your, this is your translation matrix, moving left, right, up, and down. And then they want you to find the image of the curve with equation, this is your original equation, under that transformation. So what is this equation turning into? That's pretty much the question. And just for the basis of this video, we're going to be going through a full matrices technique, so no mapping. If you want to learn the mapping technique, please refer to the previous video. I'll leave a pop-up above that you can click on to find that. But for the purposes of this video, it's going to be fully matrices. So let's get into the question. We've got ax plus b equals to x prime, and essentially you want to find this new graph over here. And the way you do this, essentially similar to what you do with mapping, is you make x the subject, right? You want to make x in terms of x prime, because then in that case, once you have the original in terms of the new x's, you can sub that into these y and x's over here to get your new graph, as what we've done previously. But using matrices, it's a bit different. So once you have ax plus b equals to x prime, and you want to make x the subject, then what do you have to do first? Well, basic matrices that you learned in year 11, you move the b over to the other side. You have x prime minus b. And then what you do with the a over here is you multiply, and the order matters, the a inverse. First, you multiply the a inverse by the a, and then followed by the x. And if you multiply the a inverse on the left hand side, you have to do it here as well. So that comes first, and then multiply by your x prime minus b. So the reason why we multiply by the dilation, or a in this case, by its inverse, is whenever you multiply matrices by its inverse, you get an identity matrix, which is essentially the 1 0 0 1, and that is multiplied by x, and over here that's the same. And the reason why we get the reason why we wanted the identity matrix is it's in its name. Anything multiplied by the identity matrix remains the same, it doesn't change. So there we go. Now you have x in terms of x prime. So this is basically kind of like the theoretical concept of this. Now we just have to apply it to the actual question itself. So the components you need to find x in terms of x prime is a inverse and of course negative b. So let's have a look at what a inverse would be. If you remember, the formula is a over ad minus bc. And then if this is a, so if this is your matrix a b c d, then what you do is you flip the a and d, so you get d and a instead, and then the b and the c just stays there, but you have a negative value for that. So that's your a inverse, and if we were to apply it over here, then a inverse would be 1 over ad. ad is negative 3 times negative 2, which is 6, and then minus bc, which is 0 times 0. Doesn't change. D and a swaps places, so negative 2 and negative 3 just swaps. And then the negative b and the negative c, well, because they're 0, it doesn't matter if you multiply by negative, it stays the same. And if I was to simplify this a little bit, then you get, 1 over 6 times everything in here. So you get negative 1 on 3, 0, 0, and then you get negative 1 on 2. There we go. So that's a inverse, and all you have to do, guys, is now, expand your matrices. We have x, which is, just x, or in this case, x, if you want to put in matrices, I'll show that later. But this is your a inverse, negative 1 on 3, 0, 0, negative half, multiply by, bracket, x prime, which is your new x and your new y, minus b. So what is b? Well, b is negative 1 and 2, right? So negative 1 and 2, put that in there, and this is where I wanted to show you. The x essentially is written as, well, your x and y, original. And then over here is your dilation / reflection matrix. And then you multiply it by, well, let's subtract these two matrices together. X prime minus 1, you get x prime plus 1. And then y prime minus positive 2, you get y prime minus 2. And then guys, what you can do is you can expand this out, and you have the old x and the old y equals to, just multiply your matrices. So -1/3 times that plus 0 times that. So you're just left with -1/3 x plus 1. I'm going to leave it there and not expand it, because later on you're going to have to sub this back into this equation right here, and you can kind of see, it gets a bit messy. So let's just leave it there first. We can expand it later if we need to. Again, the 0 you can multiply by the x, and then the -½ multiplied by the y component here, and you get -½ times by y prime minus 2, and you have a pretty good looking graph now, or looking matrix. So you can equate these together, and you get x equals to -1/3 x prime plus 1, and you have y equals to -½ y prime minus 2. So guys, what we've been doing in this video is essentially, it's the mapping technique, but without the mapping. You're just using matrices to arrive later on into this final component, and this is the important part. With all techniques, mapping or matrices, you want to always arrive at this component, which you can then sub it back into your original equation, because now we have x in terms of your new x, y in terms of your new y, so you can just sub it back into these x's and y's to get your new graph, and that's it. So I'm going to do that very quickly. So I'm going to write that here. This is my original equation, -2x³ plus 6x² plus 2, and we are going to just sub those numbers in. So my old y is equivalent to -½ y dash minus 2, which is equals to -2 times by my old x, which another way of writing it is -1/3 x prime plus 1, and then we cube the whole thing, because that's your old x, plus 6, and then everything's going to get squared. And what's the old x? Well, this is our same expression, and then plus 2 at the end. Now the hard part is done, guys. The easy part comes over here, although you have to be very careful, especially in your second year exam. You'll get 2 out of 3 marks at this point. You need to make sure you get the final answer right, okay? So do your algebra, do it slowly, and one step at a time. Don't mix things up, and then you'll get there. So I'm gonna speed the video, but so it's easy for you guys to see, and I'll start doing the questions. If you take out -2/27, this becomes a positive number, because you're taking out the negative as well. So then that leaves you with an 18 over in the second term. So you get 18x² plus 18 times 2, which is 36x plus 18. And then if you take the negative out of this one, well, that means it's a positive. And then if you're taking 2 out of 27, then you are left with a 27. That is 20 plus 27, which is 47. And guys, that is your final answer. So to how this graph right here, originally, under this transformation given to you, turns into your new graph. So as at the bottom over here. So in my opinion, your final answer can be left off at around this stage. But if you want to expand, you want to get the same answer to the book, then you can keep going a little bit further and get to this form. So guys, hopefully you found this video useful, and if you did, please leave a like, subscribe to Hok'stutoring because I would really appreciate that. Otherwise, thanks for watching, and I'll see you in the next video.